Hello out there friends, and welcome to this video today in our YouTube channel. In today's video we shall be looking at the correction of the further mathematics northwest mock of 2024. We shall be looking at the second question that is based on partial fractions and integrations. So guys, please, if you are new to our channel, please make sure you hit the subscribe button right now and press the notification icon such that each time we upload videos you will be the first person to be notified. And guys, please don't forget to press the like button beneath this video, because that is going to motivate me enough. That is actually going to tell me that you actually found contents like this so useful and I should keep doing them. And guys, once I see so many subscribers and so many likes and shares, I am going to keep doing so for you guys. Thank you very much indeed. But please subscribe, because you can only watch my next video if only you're a subscriber, because most of my contents now have been restricted. So please just press the like button and the subscribe button so that you have access to view all of them. Thank you very much indeed. Okay, let's jump straight into the video today. Okay, the first question is saying that we should express f of x into partial fractions, where f of x equal to 4 over 1 minus x squared into 1 plus x squared. And the next part is saying that we should hence show that the definite integral going from 0 to 1 by root 3 of 4 over 1 minus x to the fourth dx is the same like the natural log of square root of 3 plus 1 all that on square root of 3 minus 1 plus pi over 3. Okay guys, let's start with the first part. Guys, keep in mind that f of x is the same like 4 over 1 minus x squared into 1 plus x squared. We see that 1 minus x squared, right, is quadratic, right? Great, but it is still factorable. We can see factor it out. Then 1 plus x squared is quadratic, but it is not factored. We cannot factor it out with real numbers conveniently. So in this case, guys, now we are going to say that 4 over 1 minus x squared into 1 plus x squared is the same like 4 over, because if we factor out this 1 minus x squared, which is like the difference of two squares, we are going to have 1 minus x into 1 plus x, then into we have 1 plus x squared. Alright guys, we see that since we now have two linear factors, namely 1 minus x into 1 plus x, our first we are going to set the guys to be identically equal to a over the first guy, which is 1 minus x, since it's a linear factor, plus a constant again b other than 1 plus x. Now since the next guy now is quadratic, so what we expect to have up is what is the general form of a linear equation, namely cx plus d. Alright, good. So now if we multiply all through of this equation now by the LCM, if we now multiply all through by the LCM, namely 1 minus x into 1 plus x into 1 plus x squared, we are simply just going to have a into 1 plus x all over this, because if you multiply all through by the LCM, we'll see that 1 minus x, they will cancel this way, so we simply have a multiplying 1 plus x into 1 plus x squared as we have here. Likewise, 1 plus x will cancel for b, then we have b into 1 minus x into 1 plus x squared. Then 1 plus x squared will cancel for cx plus d, and we simply have cx plus d into 1 minus x into 1 plus x. All that should be identically equal to 4, because all the LCM here will cancel here in the case of 4, giving you just 4. So in this case now, if we start by letting our x to be 1, if we let x be 1, we'll see that putting 1 here, we are going to have 1 minus 1, which gives you 0. Everything under this b has died down. Likewise, everything under cx plus d has also died down. So if you plug in 1 here, you are going to have 1 squared. 1 squared plus 1, 1 squared is 1. 1 plus 1 gives you 2. Then there's another 1 here. 2 times 2 gives you 4. So we are simply going to have our 4a, which is equal to 4. 4a equal to this 4. That therefore implies we divide all through by 4. We are going to have our a to give us 1. Good. So this is the first value of a that we have. Okay, now Secondly, now if we let our x now to be -1, putting x to -1 implies we're going to have 1 minus x, which gives us 0. Every term here is dead. Likewise, every term here is also dead. We are simply going to have our b into, now putting x to -1, we're simply going to have 1 minus 1, which is going to be 1 plus 1, which is 2. Then -1 squared is 1. 1 plus 1 is 2, plus it, and that 2 we have here, 2 times 2 gives us 4. So we simply have our 4b to give us 4. We have 4b here to give us this 4. That therefore implies we divide all by b again. We are simply going to have, we divide all by 4. Sorry, we are going to have our b to be 1. Good. So this is the other guy. Now, guys, if you look at here, you see that I put 3 strokes, right? Most mistakes that most students make is that they just put an equal to sign. Please, this is an identity. An identity is true for all values of x, all values of the unknown, all. So it is true for all values of x in this case. So we can let x be anything, and it will still solve our problem for us. So now, if I let my x be 0 in this case, if I let x to be 0 and I plug in 0 here, 0 here, I simply have a times 1, 1. Then if I let my x to be 0 here as well, 0, 0, I just have 1 times 1, which is 1, times b gives me b. X here is 0. That therefore means that this c is dead, right? C to 0. Then 0, 0, I simply have d. So at the end result, I'm still going to have my a plus b plus d, which is giving me 4. Great. But keep in mind, guys, that I know the values of a and b, right? I know the values of a and b. So if I simply plug in my 1 here and 1 here, I'm going to have 1 plus 1, which gives me 2. Carry it to the right hand side, I'm going to have 4 minus 2. That therefore means that I'm going to have my d to my d is simply going to give me 2. Now, when my x is 2, if my x becomes 2, guys, if x becomes 2, I'm simply going to have, plug in the 2 here, I'm going to have 2 squared, which is 4. 4 plus 1 is 5. Then 2 plus 1 is 3. So 5 times 3, I simply have for 15a. That's why the 15 is here. I have 15a. Then now, if x becomes 2, 2 squared is 4, plus 1, 5. Then 1 minus 2 simply gives me what? -1. So I have 5 minus times -1, which is -5b, as I have it here. Then now, if this guy becomes 2, this is only -1, because 1 minus 2 is simply -1. Then I'm not going to have 1 plus 2, which is 3. Then here is 2. 3 times -1 gives me -3. Multiplying here, I have -3. Because here is 2, I have -6c here. Then here is just 1. I have minus 3d. That is equal to 4. But keep in mind that I know the values of a, b, and d. So now, if I solve for c conveniently, now I'm still going to have my c to be 0, because if we plug in our a, since a and b are both 1s, we are going to have 15 minus 5, which gives us 10. Then our d is -2, right? Our d is 2, sorry. So this is going to be 6. So we have 10 minus 6, which gives us 4. Carry the other side, we have 4 minus 4, which gives us 0. So we are going to have our c to be 0. So guys, these are the values of a, b, and c and d we are fine. Now, an important hint, we should know that once you've defined everything here, that this is identically equal to a into that plus b into that plus c into that, what the examiner wants to see is just the values of a and b, right? Yes, even if you don't substitute your values at the end, you have scored the entire marks, because you've defined your a, b, c, and d. You've placed them where they rightfully belong, and you've solved for them. So guys, that's it. So let's now look at this next part, how you can evaluate this definite integral. Let's look at it, guys. Hope you understood everything here. Let's look at it. Okay, now this is what we have. The question wants us to evaluate this the definite integral going from 0 to 1 by root 3 of 4 over 1 minus x raised to the power 4. Keep in mind, guys, that if you factor out this guy, 1 minus x raised to the power 4, we are going to have back what we had initially. So we should know that the definite integral going from 0 to 1 by root 3 of 4 over 1 minus x to the power 4 dx is the same like the definite integral going from 0 to 1 by root 3 of 4, like I said, over 1 minus x into 1 plus x into 1 plus x squared. Because if we factor out this guy, this is what we'll have. If we multiply these guys out, we are still going to have back this. And we already express this guy in partial fractions, right? We express this man in partial fractions already, so we are going to make use of it to have the integral going from 0 to 1 by root 3. We see we've plugged in the values of a, b, and c, a, b, c, and d already. Keep in mind that c was 0. That's why we have no term here that contains x. Good. So this is what we have. Now we see that this is 1 over a linear factor. 1 over a linear factor. All we expect to get is what? Is the natural log. So now integrating 1 over 1 minus x dx, we are simply going to have the natural log of the absolute value of 1 minus x. But keep in mind that the chain rule says we look at 1 minus x and divide by the derivative, which is just negative 1. So we just have negative in front of that guy. So if we do that, so well, we are going to have negative the natural log of absolute value of 1 minus x plus natural log of the absolute value of 1 plus x. Good. I'm putting absolute value sign because we don't want what should be inside the natural logarithm to be negative, right? Because natural log is not defined for negative values or for 0. It is not defined. So this is what we have. Then now integrating 2 over 1 plus x squared, we are simply going to keep the 2 outside. Then integrating 1 over 1 plus x squared, as we all know, guys, is what? The inverse tangent of x. So it's tan inverse of x. So the limits of these guys are from 0 to 1 by root 3. Good. From 0 to 1 by root 3. Then integrating 2 over 1 plus x squared simply gives us 2 times the tan inverse of that. So now in the next step, guys, we are simply going to have this. We have all of this. Now I have not put a limit here, but I'll evaluate it down here. Then we have 2 over tan inverse of x, like I said. So this is what we have. And since this is a definite integral, we are not going to put plus c because our answer must end up giving us this constant here. It must give us constant value here. So now if we plug in the limits, guys, if we plug in 1 by root 3, keep in mind that if you plug in 0, everything here dies down. Natural log of 1 is 0, everything 0. So we are going to subtract with 0. So we plug in 1 by root 3, we are simply going to have 1 minus 1 by root 3 here. Here we have 1 plus 1 by root 3 plus, now guys, the tan inverse of 1 by root 3 gives us 30 degrees, and 30 degrees in radians is pi over 6. The 2 reduces the 6 and gives us pi over 3. Then minus plugging in the lower limit, which is going to be 0, into all the x's, we simply have 0. So according to our law of indices, we can combine these two. If we combine these two guys, keep in mind that there's a negative sign here, so we are going to apply the difference, the division rule of logarithms, which says that if we have the difference of two natural logarithms, it is just going to be the natural log of this guy of the interior all over the natural log of this other interior. Good. So if we do that so well, we are going to have the natural log of this guy all over this guy, since the negative is here, then now plus pi over 3. So guys, if we multiply all through by the square root of 3, all through by the square root of 3, we are simply going to have 1 plus, we are going to have the natural log of 1 plus 1 by square root of 3. We multiply that with square root of 3. We do same here. This square root of 3 multiplies 1 and gives us square root of 3. Here it cancels. Here multiplies and gives us square root of 3. Here it cancels as well. So we are simply going to have our proof coming out. The natural log of the square root of 1 of natural log of the square root of 3 plus 1, all that on the square root of 3 minus 1 plus pi over 3. So as required, guys, as required. So thank you very much, guys, for watching the video, and I hope to see you in the next video. Guys, please don't forget to subscribe to this channel so that you're going to have access to all our great contents. Don't forget to check out the channel every day of the week, every day, because we shall be uploading contents every day, but those contents shall be visible mostly to subscribers. So guys, please, I highly encourage all of you to subscribe to the channel and like this video, because it does motivate me enough to keep producing great content for you. Thank you very much for subscribing, thank you for liking, and let's dive and have a great day, guys.